Yes, students, today we are discussing alternating current. So here you can see some of the pictures for the alternating current. Yes. So whatever the figures you are observing, so it is obvious that by using these alternating current, we are able to run these devices in our day-to-day life. So alternating current, how much it is important in our day-to-day life, because whatever the electronic gadgets we are using in the home, that is because of the AC source. Okay. So let us discuss what you mean by the alternating current. What are the different gadgets we are using by using the AC? So first we need to understand what you mean by the alternating current. See here, it is the current which varies in both magnitude as well as direction alternatively and periodically. How you can define alternating current here? Alternating current is defined as, it is nothing but it is the current which varies in direction as well as in terms of time. Okay, so that is, here you can represent the alternating current in this way, the sign representation, the graphical representation you can call. The alternating current is represented like this. So the DC current anta ಏನು ಹೇಳ್ತೀವಿ, that is a direct current, it is a unidirectional ಇರುತ್ತೆ. So this is the representation of the DC current and this is the representation of the AC current. So here what is happening, that is after every half cycle it is changing the direction. That is called as what? Alternating current. So in the previous chapter you come across with this expression. ನೀವು ಇಲ್ಲಿ ಏನೊಂದು expression ನೋಡ್ತಾ ಇದ್ದೀರಾ, that is I is equal to I naught sin omega t, and here the I is the current which you need to calculate here. I naught sin omega t anta ide, where this I naught is called as, it is called as the peak value or the maximum value of AC we can call. What is omega here? Omega is called as the angular frequency. So we can also write this angular frequency in terms of linear frequency it as what? That is 2 pi f anta bariತೀವಿ. ಹೌದಾ? T is the time interval. Okay, so this is how we can represent the alternating current. Here I is called as the instant value of the current, instantaneous value of the alternating current anta ಹೇಳ್ತೀವಿ. Similarly we can define, ಇಲ್ಲಿ ಯಾವ ರೀತಿಯಾಗಿ ನೀವು ಕರೆಂಟ್ ಅನ್ನ ಡಿಫೈನ್ ಮಾಡ್ತೀರಾ ಅದೇ ರೀತಿಯಾಗಿ alternating EMF ಕೂಡ ಡಿಫೈನ್ ಮಾಡಬಹುದು ನಾವಿಲ್ಲಿ. The alternating EMF is nothing but it is represented by the equation V is equal to V naught sin omega t, where V is called as the instantaneous EMF, ಮತ್ತೆ V naught anna it is called as the peak or the maximum value of voltage anta ಹೇಳ್ತಾರೆ. It is called as peak or maximum value of voltage. Okay, so hagadre here we are repeatedly saying the peak value. So what do you mean by the peak value here, students? So peak value means, or the peak value or the maximum value is nothing but it is the maximum value, it is the maximum value of AC in either half cycle. It is the maximum value of AC in either half cycle of AC is called as what? That is the peak value or the maximum value we can say. Okay, so here we define with one more term that is called as the mean value or the average value of AC. So what is the mean value or the average value of AC? Mean value is nothing but mean of all the instantaneous values. So here instantaneous value of current ಯಾವ ರೀತಿಯಾಗಿ define ಮಾಡಿದ್ವಿ? I ಅಂತ. So I1 plus I2 plus I3, the mean value of this of alternating current is taken over either half cycle ಅಂತ ಅಂದ್ರೆ. So for example, this is half cycle, this is complete one cycle. Hoda. So here to here, this is complete one cycle. So for this half cycle, whatever the current you are using, This is I1, this is I2, this is I3, I4. So this mean is called as what? Mean value of AC, or it is also called as the average value of AC anta ಹೇಳ್ತಾರೆ. So what is the relation between the mean value and the peak value? You understood what is peak value and the mean value. ಹಾಗಾದ್ರೆ ಎರಡಕ್ಕೂ relation ಏನಿದೆ ಅಂತ ಬರ್ದಿಟ್ಕೊಳ್ಳಿ. The mean value of AC is equal to 2 divided by pi into the peak value of AC, into the peak value of AC ಅಂತ ಹೇಳ್ಬೋದು. Okay. So how you are writing for the current? Similarly, you can write it for EMF also. This is the relation between the mean value and the peak value. The next one we have, that is the effective value or the every RMS value of the AC. See, what is the effective value or the RMS value of AC? So RMS means root mean square. So it is nothing but root mean square. So as the term indicates, root mean square anta andre. So whatever the current is there, first you need to square that. Okay, root mean square. So you need to take the mean of the current, again square irutte, adar mean tagolbekagate, and root. You need to put a root for that. So simple agi nanu nimage ಹೇಳ್ತಾ ಇದ್ದೀನಿ, it is called as the RMS value of AC for the current, ಅಥವಾ ಇದನ್ನ effective value ಅಂತ ಕೂಡ ಹೇಳ್ತಾರೆ. Okay, so how you can define it? Definition ಸ್ವಲ್ಪ complicated ಆಗುತ್ತೆ. If you remember with the equation, it will be easy to understand. See, it is defined as the value of AC over one complete cycle, which would generate same amount of heat in a given resistors, that is generated by the steady current in the same resistor and in the same time during a complete cycle. So this RMS value of current is nothing but what? For one cycle, how much heat it is producing, that is equal to the heating effect produced by the steady current in the same resistor. So that is called as what? That current is called as what? RMS value of AC. So nimge expression bekadre ನಾವು RMS ಅನ್ನ ಈ ರೀತಿಯಾಗಿ ಬರಿತೀವಿ. Okay, first squaring the terms, then next taking the mean of the terms, and next taking the root of the given terms. Yes, we were seeing the Just if it is visible, just check. Otherwise, once again, I'll share it. Yes, now it is visible. See. Okay, here you can see how the AC current is represented. So now what we were writing the formula list for the EMF and for the current. So for the current, it is I is equal to I naught sine omega t. And the relation between the mean value of the current and the peak value of the current is, it is pi divided by 2 into V naught, sorry, I naught. And now the IRMS is equal to I naught divided by root 2. Okay, it is I naught divided by root 2. Similarly, we can write these expression for the EMF also, students. That is, for the alternating voltage, it is given by V is equal to V naught sine omega t. Similarly, Im, mean value, Vm is equal to pi divided by 2 V naught. Similarly, VRMS is equal to V naught divided by root 2. So, allellela I ide adu replace ಮಾಡಿ V ಅಂತ ತಗೊಂಡ್ರೆ ಆಯ್ತು. Okay. Just replace it V by I by V. Okay. So, here one more point you remember, students. Here sometimes the question is asked to calculate IRMS ಇರಬಹುದು, ಏನೇ ಒಂದು ವ್ಯಾಲ್ಯೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬೇಕಾದ್ರೆ. So ಇಲ್ಲಿ ನೀವು one value ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, 1 upon root 2 is nearly it is taken as 0.7. Okay, so ಹಾಗಾದ್ರೆ I naught value ಅಷ್ಟೇ ಗೊತ್ತಿದ್ರೆ ನೀವು ಅದು root 2 ಗೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ಆಗುತ್ತೆ, ಅಂದ್ರೆ 0.7 ಗೆ, ಕರೆಕ್ಟ್. So just remember 1 upon root 2 is nearly equal to 0.7 ಅಂತ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. Okay. Yes. So this is regarding what all we have discussed. We have discussed regarding the current, the instantaneous current, the mean value of the current, the IRMS value of the current. This much we have discussed. Similarly with the voltage, these points we have covered. Now we are discussing one derivation, one very small derivation. That is, when the AC circuit is consisting of, the register, only the register. So circuit ಅಲ್ಲಿ ಏನಿದೆ ಬರೀ register ಮಾತ್ರ ಇದೆ. A register matra iddaga, what is the expression for that we are discussing. So for that, here see what we are going to do in case of the pure register. Yes. So first, what I told, your AC source ಅನ್ನ ಈ ರೀತಿಯಾಗಿ ತೋರಿಸ್ತಾರೆ. Okay. So ನೀವು ಬ್ಯಾಟರಿ ಸಿಂಬಲ್ ನೋಡಿದ್ರಿ, ರೆಜಿಸ್ಟರ್ ನೋಡಿದ್ರಿ, ಕೆಪಾಸಿಟರ್ ನೋಡಿದ್ರಿ, ಇಂಡಕ್ಟರ್ ನೋಡಿದ್ರಿ. Yes. So now the AC circuit symbol is this way. Circle irutte, ee ರೀತಿಯಾಗಿ cross line irutte. Here we are having the resistor. The resistance of the resistor is taken as R. The resistance of the resistor is how much? It is R. Okay. So next what we are doing here, we are deriving the expression for current and the voltage in case of the resistor consisting of a AC source. So AC source iddaga, the circuit is consisting of only a resistor. Here, as you know that the instantaneous EMF sin omega t anta ಬರ್ದಿದ್ವಿ. I'll consider this as equation 1 because AC source ಇರೋದ್ರಿಂದ ನಮ್ಗೆ already EMF value ಗೊತ್ತು. It is V is equal to naught sin omega t. Okay, where V naught is the peak value, omega is the angular frequency. Correct. So according to Ohm's law, students, what is current is equal to? Current is equal to V divided by R anta ಬರಿತೀವಿ. This is equation 2. What is the value of V here? V is written as V naught sin omega t divided by it is R. ಸೊ ಫುಲ್ ಡಿವೈಡೆಡ್ ಬೈ ಬರುತ್ತೆ. ನಾನು ಜಸ್ಟ್ ಇಲ್ಲಷ್ಟೇ ತಗೊಳ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಇಟ್ ಇಸ್ ವಿ ನಾಟ್ ಡಿವೈಡೆಡ್ ಬೈ ಆರ್ ಸೈನ್ ಒಮೆಗಾ ಟಿ. ದಿಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು, so what is V naught divided by R? The V naught divided by R is nothing but, that is voltage by resistance is nothing but current. So V naught irodrinda illa I naught anta tagolli, therefore it becomes I naught sin omega t. So what we derived here students, that is I is equal to I naught sin omega t anta bandide. I'll name it as equation 3. Yes. So now by seeing the equation 1 and 2, equation 1 and 2 dalli sin omega t ಅಷ್ಟೇ ನಾವು ನೋಡ್ತಾ ಇದೀವಿ. We are not seeing in any of the terms sin omega t plus pi by 2 agli, sin omega t plus pi by 4 or sin omega t plus pi by minus pi by 2 ಈ ರೀತಿಯಾಗಿ ನಮ್ಗೆ ಏನು ಕಾಣಿಸ್ತಾ ಇಲ್ಲ. So what is the meaning of this one? That is, there is no phase difference ಅಂತ ಹೇಳ್ಬೋದು. There is no phase difference when you have only a resistor in the AC circuit. So AC circuit ಅಲ್ಲಿ ಬರೀ resistor iddaga, there is no phase difference between the current and the voltage. Therefore graphically you can just show this is for the voltage and here you can show it for the current. IR anta tagolana bekadre, IR VR anta andre the circuit consists of resistor only. So ide ರೀತಿಯಾಗಿ ನಾವು ಇಲ್ಲಿ ಮತ್ತೊಂದು ಗ್ರಾಫ್ ಅನ್ನ ಕೂಡ ಹಾಕಬಹುದು. So this is representing the voltage, this is representing the voltage, and here we have the current. So phase difference enu illa, you can just see this is for the current and this is for the voltage. Okay, you can take it as maximum value as V naught, I naught. But ನೀವು ಇಲ್ಲ ಒಂದು ಕ್ವಶನ್ ಕೇಳಬಹುದು ಸ್ಟೂಡೆಂಟ್ಸ್, ನಿಮ್ದು ಗ್ರಾಫ್ ಅಲ್ಲಿ ಯು ಆರ್ ಶೋಯಿಂಗ್ ದ ಕರ್ವ್, ವೋಲ್ಟೇಜ್ ಕರ್ವ್ ಮೇಲ್ ತೋರಿಸ್ತಾ ಇದ್ದೀರಾ, ಕರೆಂಟ್ ಕರ್ವ್ ಅನ್ನ ಸ್ವಲ್ಪ ಕೆಳಗಡೆ ತಗೊಳ್ತಾ ಇದ್ದೀರಾ. Why not it is like this? Voltage ಕೆಳಗಡೆ ಬಂದು ಕರೆಂಟ್ ಮೇಲ್ ಮಾಡಬಹುದಾ? Or both we can show simultaneously, or this is right. Yes, see why we are showing the voltage here and the current ಸ್ವಲ್ಪ ಕಡಿಮೆ ಯಾಕೆ ತೋರಿಸ್ತಾ ಇದೀವಿ ಅಂತ ಅಂದ್ರೆ, because what is your current is equal to, current is equal to V divided by R. ಹೌದಾ, V divided by R ಇದೆ ಅಂದ್ರೆ ವೋಲ್ಟೇಜ್ ಏನ್ ವ್ಯಾಲ್ಯೂ ಇದೆ ಅದಕ್ಕೆ ಡಿವೈಡ್ ಮಾಡಿ ಏನೋ ಒಂದು ಕ್ವಾಂಟಿಟಿಯನ್ನ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಅಂದ್ರೆ ಆನ್ಸರ್ ಏನಿರುತ್ತೆ, I will be lesser than your V value. So therefore the graph we are representing in this way ಅಂತ ಹೇಳ್ಬೋದು. Okay, so here this is the voltage curve ಮತ್ತೆ ಕರೆಂಟ್ ಸ್ವಲ್ಪ ಕಡಿಮೆ ಬರುತ್ತೆ, but there is no phase difference. phase difference ಇದ್ರೆ ಈ ತರ ಬರಲ್ಲ. phase difference ಇದ್ರೆ ಯಾವ ರೀತಿಯಾಗಿ ಬರುತ್ತೆ, ಇದು ವೋಲ್ಟೇಜ್ ಆದ್ರೆ ಕರೆಂಟ್ ಈ ರೀತಿಯಾಗಿ ಬರುತ್ತೆ. ಸೊ ಅದು ಬೇರೆ ಕಂಡೀಷನ್. ನೀವು ನೆಕ್ಸ್ಟ್ ಈಗ ಅರ್ಥ ಆಗತ್ತೆ ನೆಕ್ಸ್ಟ್ ಡೆರಿವೇಶನ್ಸ್ ಅನ್ನ ನೋಡಿದಾಗ. Yes, now you tell me whether it is clear to you. When the AC circuit consists of only a resistor, what is the expression for current, what is the expression for voltage? So what you need to remember here is, that is the phase difference between both, it is what, it is 0. The phase difference will be 0. Yes, clear to you? Yes students, is it clear?
Yes ma'am.
Okay. Yes, now you see the next one. ಅಂದ್ರೆ ನಿಮಗೆ ಸ್ವಲ್ಪ ಕಂಪ್ಯಾರಿಸನ್ ಮಾಡಿದಾಗ ಸ್ವಲ್ಪ ಕ್ಲಿಯರ್ ಆಗಿ ಅರ್ಥ ಆಗತ್ತೆ. We will see one more derivation. That is, the AC circuit consists of a pure inductor. So pure inductor ತಗೊಳ್ಬಹುದು ಅಥವಾ pure conductor capacitor ಕೂಡ ತಗೊಳ್ಬಹುದು. ಮೂರು derivation ಇದೆ ಇಲ್ಲಿ. So which will come for 2 marks. The AC circuit consists of resistor, AC circuit consists of inductor, AC circuit consists of a capacitor. So now we have seen the expression for the AC circuit consists of a resistor ನೋಡಿದ್ವಿ. ಈಗ ಪ್ಯೂರ್ ಇಂಡಕ್ಟರ್ ಗೆ ನೋಡೋಣ. ಸೊ ಪ್ಯೂರ್ ಇಂಡಕ್ಟರ್ ಅಂತ ಅಂದ್ರೆ ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ, ಇಂಡಕ್ಟರ್ ಅನ್ನ ಈ ರೀತಿಯ ಕಾಯಿಲ್ ರೀತಿಯಾಗಿ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. And it is connected to the AC source. Yes, it is AC source like this circle, and like this we have, this is the AC source here, and here we are showing the inductor. Okay, so when you have the inductor in the circuit, ella derivation gu ee equation fix ide. That is, the EMF is given by V is equal to V naught sin omega t. V is equal to V naught sin omega t. Okay, now here what we are representing, see ನಾವು ಈಗ ಏನ್ ಮಾಡ್ತೀವಿ ಅಂತ ಅಂದ್ರೆ, here V naught is the peak value of the potential difference, omega is the frequency. Suppose E is the EMF induced in the circuit. E is the EMF induced, because inductor ಇರೋದ್ರಿಂದ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, EMF is induced in the circuit, correct? So when the EMF is induced in the circuit, by applying the Kirchhoff's law, ನಾನು ಏನು ಬರಿಬಹುದು ಅಂತಂದ್ರೆ, here the total EMF is what? That is V plus E. E is the induced EMF, V is the applied EMF, which is equal I to R. Okay, just it is V is equal to IR ittu. According to Kirchhoff's law, here the summation of both we are taking, that is V plus E is equal to IR anta ತಗೊಳ್ತಾ ಇದ್ದೀವಿ. So as you know that the circuit is a pure inductor circuit. ಹಾಗಾದ್ರೆ resistance value ಎಷ್ಟಿರುತ್ತೆ? Resistance value 0 ಇರುತ್ತೆ. Therefore the equation becomes V plus E is equal to what? It becomes 0. So make it as equation 2 because equation 1 is this. ಇಲ್ಲಿ ಏನು ಬರ್ದಿದ್ದೀರಾ? This is your equation 1. So equation 1, equation 2, hope so it is clear to you. Then we have the, according to the self-inductance, we have the EMF is equal to minus L di by dt. ನಿಮಗೆ ನೆನಪಿರಬಹುದು ಲಾಸ್ಟ್ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ನಾವು ಸೆಲ್ಫ್ ಇಂಡಕ್ಟೆನ್ಸ್ ಅನ್ನ ಡಿರೈವ್ ಮಾಡಲು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬರೆದಾಗ E is equal to minus di by dt, where di by dt is rate of change of current, equation 3. So let me substitute 3 in equation 2. So 3 in equation 2 ಮಾಡಿದಾಗ V minus, because plus into minus is minus, minus L di by dt, which is equal to 0. So again, if I simplify this equation, iದೇನಾಗುತ್ತೆ? V is equal to L into di by dt ಅಂತ ಆಗುತ್ತೆ. It becomes V is equal to L into di by dt. Okay. Suppose if I want only for di, that is the rate of change of current. So I want only for the change of current. ಅವಾಗ ಏನಾಗುತ್ತೆ? It becomes V divided by L into dt. It becomes V by L into dt. Correct? Make it as equation 4. Yes, equation 4 ವರೆಗೆ ಏನಾದರೂ ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ. Last 3 steps we have in the derivation. So I'll repeat here students. ನಾವೇನ್ ನೋಡ್ತಾ ಇದ್ದೀವಿ? When the AC ಸರ್ಕ್ಯೂಟ್ ಗೆ ಬರೀ ಇಂಡಕ್ಟರ್ ಇದ್ದಾಗ ಕರೆಂಟ್ ಮತ್ತೆ ವೋಲ್ಟೇಜ್ ವ್ಯಾಲ್ಯೂ ಏನ್ ಬರುತ್ತೆ? ಸೊ ವೋಲ್ಟೇಜ್ ವ್ಯಾಲ್ಯೂ ಎಲ್ಲಾ ಡೆರಿವೇಶನ್ ಅಲ್ಲಿ ಫಿಕ್ಸ್ ಇದೆ. V is equal to V naught sin omega t. So inductor ಇರೋದ್ರಿಂದ ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ it will induce the EMF in that. Therefore EMF is induced is given by, according to Kirchhoff's law, V plus E is equal to IR. So V plus E is equal to 0 ಆಗುತ್ತೆ because it is only a inductor circuit. The resistance value will be 0. So now, according to the self-inductance formula, E is equal to minus L di by dt. So therefore, V minus L di by dt is equal to, it becomes 0, which is equal to, which implies V is equal to, idenagatte, V is equal to L into di by dt. Okay, so just rearrange the terms. Terms ಅನ್ನ rearrange ಮಾಡಿದಾಗ ನಮಗೆ ಏನು ಸಿಗ್ತಾ ಇದೆ? V by L is equal to dt is equal to di. Yes, still equation 4. If any doubt is there, please ask. So further what we are doing antandre, we are just substituting the equation 4 in equation 1. So you can see what is our equation 4, that is di is equal to V by L anta ide. V value from equation 1 enittu? V is equal to V naught sin omega t divided by, it is L into dt. Correct? Suppose if I integrate this above equation, the integration of di is equal to integration of V naught sin omega t divided by L into, with respect to dt ನಾವು integrate ಮಾಡ್ತಾ ಇದ್ದೀವಿ. Okay. So ನಿಮಗೆ ಗೊತ್ತಿರಬಹುದು, because first year ಅಲ್ಲಿ ಕೆಲವೊಂದು derivations ಎಲ್ಲ ನೋಡ್ತೀವಿ. Integration of dx is equal to x, integration of dy is equal to y, integration of dz is equal to z. So similarly integration of di is equal to ಏನು ಬರುತ್ತೆ? It will be I is equal to. So ಇಲ್ಲಿ V naught by L ಅನ್ನೋದೇನಿದೆ students, it is a constant. So V naught by L, I will take it out. The integration of sin omega t into dt, which is equal to V naught by L ಅದೇ ರೀತಿಯಾಗಿ ಬರೀರಿ. Sin omega t integration students. What is sin omega t integration? The sin omega t integration ಏನು ಬರುತ್ತೆ? Minus cos omega t into omega. Okay. Sorry, not into, it is divided by omega because it is integration. Differentiation ಅಲ್ಲಿ into ಬರುತ್ತೆ. Yes, check with the steps. If any doubt is there, please ask. Yes. So integration of sine omega t is cos omega t divided by omega. It is minus cos omega t divided by omega. Okay. So now this omega, I'll just take it out. This is V naught omega into L inside the bracket. So this is minus cos omega t. So minus cos omega t anna students ನಾವು ಈ ರೀತಿಯಾಗಿ ಬರಿಬಹುದಾ? Sin omega t minus pi by 2. Sin omega t minus 90 or sin omega t minus pi by 2. Yes, ನೋಡಿ. Already you have studied the trigonometry. So ನೀವು trigonometry ಅಲ್ಲಿ ಕಲ್ತಿರ್ತೀರಾ. The minus cos omega t or minus cos theta na sin theta minus 90 ಅಂತ ಬರಿತೀವಿ. So therefore it is sin of omega t minus pi by 2. Okay. So now last step, this term ನಮ್ಗೆ ಈಗ ಏನ್ ಬಂದಿದೆ V naught by omega L, this is nothing but I naught sin of omega t minus pi by 2. Omega t minus pi by 2. ಹಾಗಾದ್ರೆ ಇದು ಏನು ಒಮೆಗಾ ಟಿ ಅಂದ್ರೆ ಏನಂತ ತಗೊಂಡ್ ಐ ನಾಟ್ ಅಂದ್ರೆ ಏನ್ ಬಂದಿದೆ ಇಲ್ಲಿ? ಐ ನಾಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ವಾಟ್ ಯುವರ್ ಐ ನಾಟ್, ವಾಟ್ ಯು ಹ್ಯಾವ್ ಟೇಕನ್ ಐ ನಾಟ್ ಅಲ್ಲ, ಈ ಐ ನಾಟ್ ಏನಿದು ವಿ ನಾಟ್ ಅಪಾನ್ ಒಮೆಗಾ ಎಲ್ ಅನ್ನ ಐ ನಾಟ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀವಿ. ವೈ ಅಂತ ನೀವು ಇಲ್ಲಿ ಕೇಳ್ಬೋದು. ಯಾಕಂತ ಅಂದ್ರೆ here as we know that according to Ohm's law I is equal to ಏನಾಗುತ್ತೆ? It becomes I is equal to V divided by R. ಹೌದಾ? So V by R is taken as current. ಬಟ್ ಇಲ್ಲಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಬದಲಾಗಿ ನಮ್ಮ ಹತ್ರ ರೆಜಿಸ್ಟರ್ ಇಲ್ಲ ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಬರೀ ನಮ್ಮ ಹತ್ರ ಇರೋದೇನು? ದಟ್ ಇಸ್ ವಿ ಹ್ಯಾವ್ ಓನ್ಲಿ ದ ಇಂಡಕ್ಟರ್. ಸೊ ಇಂಡಕ್ಟರ್ ಇರೋದ್ರಿಂದ ಇದೇನ್ ಅಪೋಸಿಷನ್ ಆಫರ್ ಮಾಡ್ತಾ ಇದೆ ಕರೆಂಟಿಗೆ? The opposition offered by the inductor for the flow of the current in the circuit is taken as omega into L. So this omega into L ಅನ್ನ ನಾವ್ ಏನಂತ ಕರಿತೀವಿ ಅಂತ ಅಂದ್ರೆ ಇಂಡಕ್ಟಿವ್ ರಿಯಾಕ್ಟನ್ಸ್. ಇಂಡಕ್ಟಿವ್, ಅದನ್ನ ಹೇಗೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಂತ ಹೇಳ್ತೀರಾ? ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಇಂಡಕ್ಟಿವ್ ರಿಯಾಕ್ಟನ್ಸ್. ಹಾಗಾದ್ರೆ ಇಂಡಕ್ಟಿವ್ ರಿಯಾಕ್ಟನ್ಸ್ ಅಂದ್ರೆ ಏನ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇಲ್ಲಿ? ಇಂಡಕ್ಟಿವ್ ರಿಯಾಕ್ಟನ್ಸ್ ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ಎ ರೆಸಿಸ್ಟೆನ್ಸ್ only which oppose the flow of the current in the given circuit when the inductor is there. So one V naught upon omega L is taken as I naught. ಹಾಗಾದ್ರೆ ಈ omega L ಅನ್ನ omega into L it is taken as XL. Just for symbol we take it as XL. XL ಅಂದ್ರೆ ಏನು? Inductive reactance. XL is nothing but what? It is inductive reactance. Yes, see? Any doubt is there in the given this one derivation? ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ನೀವು ನೋಡ್ಬೋದು ಪ್ರೀವಿಯಸ್ ಕೇಸ್ ಅಲ್ಲಿ, ಪ್ರೀವಿಯಸ್ ನೀವೇನ್ ರೆಜಿಸ್ಟರ್ ಇದ್ದಾಗ ಏನ್ ಸ್ಟಡಿ ಮಾಡಿದ್ರಿ? I is equal to I naught sin omega t, V is equal to V naught sin omega t. ಅಲ್ಲೇನು ಫೇಸ್ ಡಿಫರೆನ್ಸ್ ಬಂದಿರ್ಲಿಲ್ಲ ಎರಡರ ಮಧ್ಯೆ, ಹೌದಾ? ಬಟ್ ಈಗ ನೋಡ್ಬೋದು ನೀವು V is equal to V naught sin omega t ಇತ್ತು ಫಸ್ಟ್, ಹೌದಾ? EMF ಏನ್ ತಗೊಂಡಿದ್ವಿ? V is equal to V naught sin omega t. ಬಟ್ ಕರೆಂಟ್ ಏನ್ ಬರ್ತಾ ಇದೆ? We are getting current as what? I naught sin omega t minus pi by 2. Correct? Check. So see all the steps. ನಿಮಗೆ ಏನಾದ್ರೂ ಡೌಟ್ ಇದ್ರೆ ನೀವು ಆ ಸ್ಟೆಪ್ ಅನ್ನ ಕೇಳಿ, ನಾನು ನಿಮ್ಗೆ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀನಿ. ಅಂಡರ್ಸ್ಟೂಡ್ or ಏನು ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ? ಅರ್ಥ ಆಯ್ತಾ? ಎಸ್, ಪ್ಲೀಸ್ ಟೆಲ್. ಎಸ್, ಬೇಬಿ ಅಂಡ್ ಪವಿತ್ರ.
Yes, ma'am.
Okay. Yes. ಸೊ ಏನ್ ಹೇಳೋ ಉದ್ದೇಶ ಏನಂತ ಅಂದ್ರೆ, ನೀವು ಕರೆಂಟ್ ವೆನ್ ದ ಸರ್ಕ್ಯೂಟ್ ನಿಮ್ದೇನ್ AC ಸರ್ಕ್ಯೂಟ್ ಅನ್ನ ಬರೀ ರೆಜಿಸ್ಟರ್ ಗೆ ಅಪ್ಲೈ ಮಾಡಿದಾಗ EMF ಮತ್ತೆ ಕರೆಂಟ್ ಮಧ್ಯದಲ್ಲಿ ಏನು ಫೇಸ್ ಡಿಫರೆನ್ಸ್ ಇರ್ಲಿಲ್ಲ. ದೇರ್ ಇಸ್ ನೋ ಫೇಸ್ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದೆಮ್. ಬಟ್ ನೀವು ಯಾವಾಗ ಇಂಡಕ್ಟರ್ ಅನ್ನ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀರಾ, ರೆಜಿಸ್ಟರ್ ಅನ್ನ ತೆಗ್ದಿ ಫಾರ್ ದ AC ಸೋರ್ಸ್, the EMF and the current equation is different. So here the current we are getting it as I naught sine omega t minus pi by 2. Okay. So hೀಗಾದ್ರೆ conclusion ಏನಿಲ್ಲಿ the voltage is ahead of the current by the phase difference of pi by 2. So ಇಲ್ಲಿ ಎರಡು ರೀತಿಯಾಗಿ ಹೇಳ್ಬೋದು, voltage leading, voltage ಏನಾಗ್ತಾ ಇದೆ lead ಮಾಡ್ತಾ ಇದೆ by the factor or by the phase difference of pi by 2. ಅಥವಾ ನೀವು ಮತ್ತೊಂದು ರೀತಿಯಾಗಿ ಏನ್ ಹೇಳ್ಬೋದು ಅಂತ ಅಂದ್ರೆ the current is lagging by the phase difference of pi by 2. In both the ways you can tell. See, so current lagging athwa voltage leads by pi by 2. ಅಲ್ಲ ಆ ರೀತಿಯಾಗಿ ಇರ್ಲಿಲ್ಲ, ಹೌದಾ? ನೀವು ಇಲ್ಲಿ ಡಯಾಗ್ರಾಮ್ ನೋಡಬಹುದು ಈಗ ಸ್ಟೂಡೆಂಟ್ಸ್. ಸೊ ಇಫ್ ಯು ಸಿ ಈ ಡಯಾಗ್ರಾಮ್ ಏನಂತಾರೆ, ಇದಕ್ಕೆ ಫೇಸರ್ ಡಯಾಗ್ರಾಮ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಓಕೆನಾ? ಸೊ ಇಲ್ಲಿ ಫೇಸರ್ ಡಯಾಗ್ರಾಮ್ ನೀವು ಇಲ್ಲಿ ನೋಡಿದಾಗ, okay, so this is the x-axis, this is the y-axis. So here current ಏನಾಗ್ತಾ ಇದೆ, current is lagging. So current illirutte and the EMF is leading, therefore here it is ahead of that. So by the factor of pi by 2 anta helbodu. ಮತ್ತೆ ನೀವು ಈ ಗ್ರಾಫ್ ಅನ್ನು ನೋಡಿದಾಗ here you can see in this graph, second ಇದು first ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅದರಲ್ಲಿ. So here this is EMF, this is the graph for the EMF, and when you see the current ಇಲ್ಲಿ ಬರುತ್ತೆ, ಯಾಕೆ pi by 2 it is lagging, so therefore here it will come. And again you have to show it little down. Yes, so this is how it is represented. So please copy down the phasor diagram ಮತ್ತೆ graphical representation. ಇದೇನಿದೆ ಈ ಗ್ರಾಫ್ ಅನ್ನ ಕಾಪಿ ಡೌನ್ ಮಾಡ್ಕೊಳ್ಳಿ. This is for the ಏನಂತ ಹೇಳ್ಬೋದು, ಇದು ಇದಕ್ಕಿರುತ್ತೆ for the inductor. So in case of resistor ಇದ್ದಾಗ ಎರಡು ಒಂದೇ ಲೈನ್ ಅಲ್ಲಿ ಇತ್ತು. This is phasor diagram and graphically you just shown like this. Correct? Okay, so last point we are discussing maton derivation naale nodana for the capacitor circuit. Okay, so here what we are need to discuss is, now illon term helde nimge, that is V naught divided by omega into L is called as what? I naught anta helidvi. So this omega L is nothing but it is inductive reactance. ಇದನ್ನ XL ಇಂದ ಡಿನೋಟ್ ಮಾಡ್ತಾರೆ. Omega is also written as 2 pi f into L, which is equal to XL. Omega is nothing but 2 pi FL into 2 pi f into L. ಅದೇ ರೀತಿಯಾಗಿದೆ. Omega ಅಂದ್ರೆ 2 pi f ಅಂತ ತಗೊಳ್ತೀವಿ. So this is inductive reactance formula. So please remember the formula for the inductive reactance. Okay. So to calculate the inductive reactance, ನಿಮ್ಗೆ ಏನ್ ಬೇಕಾಗತ್ತೆ, ಒಂದು angular frequency ಬೇಕಾಗತ್ತೆ. ಇಲ್ಲ angular frequency ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ at least you should know the linear frequency. L is the self inductance ಅಥವಾ inductance ಅಂತ ಕೂಡ ಹೇಳ್ಬೋದು. Okay. So here question ನಲ್ಲಿ ನಿಮ್ಗೆ XL ಕೇಳಿದ್ದಾರೆ, but they have not given you omega also, they have not given you F also. But ನಿಮ್ಗೆ XL find out ಮಾಡ್ಬೇಕಾಗಿದೆ. Then what you will do here students? Always remember, suppose question ಅಲ್ಲಿ ನಿಮ್ಗೆ ಬೇಕಾಗಿದೆ F, okay, there is no other way to calculate without F ಅಂತ ಹೇಳಿದಾಗ ಅವ್ರು ಕೊಡ್ಲಿಲ್ಲ ಅಂದ್ರೂ ಕೂಡ ನೀವ್ ಏನ್ ಮಾಡ್ಬೋದು, you can, yes
ma'am, what is the meaning of F and L, ma'am?
L is inductance, omega is angular frequency, XL is nothing but it is the product of these two, and this is called as inductive reactance. It is called as inductive reactance. So how you define resistance? ನಿಮ್ದು ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ರೆಜಿಸ್ಟರ್ ಇದ್ದಾಗ resistance ಇರುತ್ತೆ, which is the opposition for the flow of current, ಅದನ್ನ resistance ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ನಾವೀಗ ನೋಡಿರೋ ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ನಮ್ಗೆ ರೆಜಿಸ್ಟರ್ ಇಲ್ಲ, we have only inductor. So this inductor is also opposing the flow of current. So that is called as what? Inductive reactance anta heltivi, denoted as XL. Yes, is it clear?
Yes, ma'am. About F, ma'am?
F is frequency. F is the linear frequency. Omega is the angular frequency.
Yes, ma'am.
Okay. Suppose in the question the frequency F is not given. ಲಾಸ್ಟ್ ಅಲ್ಲಿ ನಿಮ್ಗೆ ಬೇಕೇ ಆಗಿದೆ ಎಫ್ ವ್ಯಾಲ್ಯೂ ಅಂತ ಅಂದ್ರೆ ಯು ಕ್ಯಾನ್ ಕನ್ಸಿಡರ್ ದ ವ್ಯಾಲ್ಯೂ ಇಫ್ ಇಟ್ ಇಸ್ ನಾಟ್ ಗಿವನ್ ಆಲ್ಸೋ ಯು ಕ್ಯಾನ್ ಕನ್ಸಿಡರ್ ಇಟ್ ಆಸ್ 50 ಹರ್ಡ್ಸ್. ವೈ ಅಂತ ಅಂದ್ರೆ ಬಿಕಾಸ್ ನಾವು ಇಂಡಿಯಾದಲ್ಲಿ ಬಿಕಾಸ್ ಕ್ಲೈಮ್ಯಾಟಿಕ್ ಕಂಡೀಷನ್ಸ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗತ್ತೆ. ಸೊ ಇನ್ ಇಂಡಿಯಾ ದ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ದ ಎ ಸಿ ಸೋರ್ಸ್, ನಾವೇನ್ ಎ ಸಿ ಸೋರ್ಸ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಇಟ್ ಈಸ್ ಆಫ್ ದ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ 50 ಹರ್ಡ್ಸ್. So if you need it, you can consider it as 50 hertz if it is not given in the question at the extreme case. Okay, so maximum times ಕೊಟ್ಟಿರ್ತಾರೆ, ಕೊಟ್ಟಿರ್ಲಿಲ್ಲ ಅಂದ್ರೆ ನೀವು ಕೆಲವೊಂದ್ಸಲಿ 50 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು. Okay, so this is the two derivation which we discussed today. One is the inductive, the AC source consisting of the resistor. Second is AC source consisting of the inductor. Yes, any doubt is there, students? So please remember all the formulas. The lesson is consisting of many formulas ಅಂತ ಹೇಳ್ಬೋದು. Okay, so ಇವತ್ತು ಯಾವ್ದಾವ್ದು ಫಾರ್ಮುಲಾಸ್ ಅನ್ನ ನೋಡಿದ್ವಿ, ಪ್ಲೀಸ್ ಅದನ್ನ ಲಿಸ್ಟ್ ಔಟ್ ಮಾಡಿ, ಬಿಕಾಸ್ ಇನ್ ಬಿಟ್ವೀನ್ ಓನ್ಲಿ ವಿ ಕ್ಯಾನ್ ಡಿಸ್ಕಸ್ ಸಮ್ ಕ್ವಶನ್ಸ್ ಆಲ್ಸೋ, ಬಿಕಾಸ್ ಮೆನಿ ಫಾರ್ಮುಲಾಸ್ ಆರ್ ದೇರ್. ಅಂಡ್ ಐ ಟೋಲ್ಡ್ ಯು ಆಲ್ರೆಡಿ ಈ ಲೆಸನ್ ಮೇಲೆ ನಿಮ್ಗೆ ಡೆರಿವೇಶನ್ ಕೂಡ ಬರುತ್ತೆ 5 marks ಅಲ್ಲಿ, ಮತ್ತೆ ನ್ಯೂಮರಿಕಲ್ ಕೂಡ ಬರುತ್ತೆ. ಸೊ ಇಟ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಟಾಪಿಕ್ ಆಲ್ಸೋ. And for CET ಆಯ್ತು, NEET ಆಯ್ತು, JEE exam, again it is one of the important chapter with maximum weightage. So ನೀವು ಯಾವುದೇ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇದ್ರೆ ಇದು ಎಲ್ಲಾ ಎಕ್ಸಾಮ್ ಅಲ್ಲೇನು ಮ್ಯಾಕ್ಸಿಮಮ್ ವೇಟೇಜ್ ಇದೆ. So please study this properly, make a list of all the formulas. So today what all formulas we have discussed, make a list of that. Tomorrow we will continue with the next derivation. Thank you.